formation of fouling in pipes and tanks is an annoying phenomenon that cannot be ignored neither in your house nor in large-scale industrial plants. Such occurrence is related to the poor chemical and biological stability of water. In case of poor chemical stability, the observed effect is the precipitation of inorganic compounds as limestone. In detail, a solid deposit is formed when the solubility of inorganic compounds in water as calcium carbonate is exceeded. This can occur because of the high concentrations of the constitutive ions in water, as calcium ion and bicarbonate ion for limestone, but also as a consequence of a sudden change in condition, resulting in the modification of the thermodynamic equilibrium. Temperature and pH are two major factors influencing the solubility of inorganic compounds in water. A typical case in a household situation is the formation of fouling in the dishwasher, in case that the cell container is not refilled properly. In this case, the water heating is the main responsible. On the other hand, the consequence of a lack in biological stability of water is the growth of biofilm along the inner surface of pipes and tanks. Biofilm is a biological structure created by bacteria to colonize the surface. The formation process is complex, and it is based on the production of sticky substances promoting the adhesion of bacteria. As bacteria are ubiquitous in the environment and present in drinking water, the biofilm is formed in water system when nutrients are available and no inhibiting compounds are dispersed, as disinfectants. The growth of biofilm is usually promoted at higher temperature, as a consequence in the acceleration in bacterial metabolism. Due to favorable condition, the shower hose is a perfect place for biofilm formation. Fouling in pipes and tanks can result in relevant issues at the domestic and industrial scale. As for the precipitation of inorganic compounds, for example, it can cause a decrease of the heat exchange rate in boilers, the reduction of pipe section and tank volume, and the deterioration of fluid quality in productive processes. Concerning the biofilm, it can create organoleptic issues related to water use and the proliferation of opportunistic pathogenic microorganisms that can take refuge in the biofilm, as Legionella. There are mainly two approaches for limiting the occurrence of fouling in pipes and tanks, aimed at preventing the formation of fouling and removing the deposited slime. In both cases, the monitoring of fouling formation is a key element for the correct system operation. Nowadays, there are many direct and indirect instruments for fouling monitoring, based on online and offline measures. Real-time online techniques enable the development of early warning and automatic cleaning systems. It is worth mentioning that the timely detection is a key element for the successful cleaning, as thick deposits are difficult to treat. Dirty sensing is a patented sensor for the monitoring of fouling in pipes and tanks that was developed in Politecnico di Milano. The working principle is based on the change in the electrical response that is determined by the presence of fouling on the surface of an interdigitated electrode. More in detail, the formation of a biofilm on the sensor surface results in an increase in the electric field generated from the electrodes, as a consequence of the increase in conductivity determined by the high ionic concentration in the biofilm. On the contrary, inorganic deposits determine a decrease in the electrical field, as the precipitated solid matrix limits the conductivity. In both cases, for inorganic and organic fouling, the electrical response is proportional to the slime thickness. Therefore, dirty sensing is an accurate and selective instrument for the real-time and low-cost measurement of fouling. The sensors are usually positioned along the inner surface of a pipe in sensorized nodes, in which the fouling sensor is combined with several other elements: a module for the signal acquisition and processing, a wireless transmission module, a turbine for power supply based on energy harvesting from the water flux. Moreover, sensorized nodes, including several other commercial sensors, were developed for measuring additional parameters as temperature, conductivity, pressure, flow rate, and pH. Sensorized nodes are usually operated by deriving the fluid from the circuit in the target system, and the water is discharged after the passage through the node. The direct online application of the dirty sensing sensors in pipes and tanks belonging to the target system is also possible and is currently under development. Dirty Sensing Initiative started some years ago, in 2017, when the proof of concept was awarded with the switch to product prize of the Politecnico di Milano. Then, in 2019, it was selected among the 5 most relevant innovations within the Zero Power Water Monitoring Challenge promoted by the European Commission. Specifically targeting the price goal, the wireless transmission and the energy harvesting modules were developed and the whole system was validated in a relevant environment. Nowadays, a long-lasting pilot-scale testing campaign for the demonstration in relevant environment is on the way. With 3 different operation sites where the solution is applied to the monitoring of the drinking water infrastructure of 2 water utilities in Italy, respectively focusing on the formation potential of inorganic and organic fouling in the distribution network. The solution has also great potential for some other sectors, as energy and food processing, where the attention to inorganic deposits in water circuits and the preservation of microbiological characteristics are of paramount importance. To understand the importance of the latter aspect, consider the increasing concern for food microbiological pollution and related impacts on human health, as the case of Listeria, recently reported in the news. Looking at future developments, it is possible to imagine that the dirty sensing solution and other emerging online sensors could be integrated within smart city facilities and Industry 4.0 plants, so that the control of fouling could be completely automated by the combination of real-time monitoring techniques with advanced modeling and control tools. The best is yet to come. Stay with me.